Hey everyone, thanks so much for joining us today. I am super excited to be here with Zuzana Matavasian from MongoDB. I hope you guys are having an amazing time, and I am so excited about our topic today because we're going to be diving a little bit deeper into what it means to analyze some real world data. So if you're new to IBM Developer, I wanted to let you know that we host online meetups, lunch and learns, workshops, and other developer education events to help you tackle some of your biggest technical challenges. If you are interested, feel free to follow our Crowdcast account to stay up to date with some of our most latest events. And you can actually follow us and kind of get all the updates on all of our series. So today I'm here with, as I mentioned, I'm here with Zuzana from MongoDB, and we're going to be talking about just working with real world data. And before we get started, I just wanted to go over a couple of guidelines. If you have some questions, feel free to add them in the chat window and say hi and discuss any topics that are relevant. And then if you are interested in rewatching this replay, you can find us at the same link you're at. So before we get started, I wanted to just hand it off to Zuzana and have her introduce herself.
Hi, everyone. My name is Zuzana Matevosian, and I'm a Senior Solutions Architect at MongoDB. I'm super excited to be here joining the IBM dev community, and really excited to talk to you guys about some of the work we do with the Internet of Things at MongoDB.
Awesome. All right, Zuz. Well, thanks for joining us. I know this is going to be a really insightful session. I'm super excited to just kind of dive right in. So let's get started.
Great. Excellent. So, like I said, today we will be talking about MongoDB and the Internet of Things. We'll do a quick intro of just what Mongo is. Mongo has probably changed from what you've seen or heard about it even like 2-3 years ago. So I always like to go back and just chat a little bit about some of the changes, and then we will really dive into some of the IoT use cases and some of the features that make us really relevant within the IoT space. So let's get started.
Awesome. Yeah.
Great. So first and foremost, as you all know, today a company's competitive advantage is very often about the data. So it's really the data that we have about our customers, about our things, and it's what gives companies competitive advantage. It helps to fuel innovation, and unfortunately, about 70% of enterprises fail in their digital transformation initiatives. So while we all know that data is really important and at the heart of what we do, we also don't always deliver on it. And there are many reasons why that happens. The data infrastructure is generally fairly complex. While modern applications, they want to be highly responsive, relevant, mobile first, private, compliant, and always improving. I think this is one of the things that actually ends up really distinguishing certain organizations from others, where if you can develop a new feature, deliver maybe not even on the timeline, but before your deadline hits, that's where you have that innovative edge, when you are not constrained so that you cannot iterate and deliver quickly. And that's because, very often we see that when people are not able to deliver quickly, it might be because they're working with certain parts of their infrastructure, very often a data infrastructure, that is somewhat old. I mean, when you think about it, RDBMS has been around for almost 40 years. That's quite a while. While if you look at some of the new dynamic languages that people are writing in, it's maybe 10 years, maybe less. So the evolution that we've seen in the application space has not been fully mirrored in the database space. And what happens when we don't have applications that are continuously talking to databases that enable that application evolution is that we end up with systems like this one, where you have a lot of ETLs, a lot of transformations going on between different data layers, between different databases, and kind of taking this kind of an architecture and stitching it together is not very simple. It's not very fast, and it doesn't really lend itself well to being on that cutting edge in terms of delivering new features and delivering them quickly. Just if you look right here, right, we have our IoT Edge DB right here on the right. And for it to actually go and interact with any application, it has to sync, then it has to go through a transformation layer, then it has to go and live either in some GraphDB or a document DB. Then that itself needs to be transformed to go into a relational database. And that maybe makes it to the application layer. So you see that all of these levels of separation for your data end up slowing down the development, because if you want to make a change, you suddenly need to update and change all of these different parts that communicate and that are a part of that data pipeline. And so when we see this happening, we see a lot of issues coming up. Things like fragmented developer experience, operational and security model rationalization, significant effort to integrate all of this data, and of course, a lot of data duplication. I mean, who hasn't heard of data silos where one part of your organization has one data that looks very similar to another part of the organization? So with that, we really see this complexity creating a tax on innovation, which we call the DIRT, the data and innovation recurring tax. And with that, this is where Mongo comes in. That's the problem we are trying to solve. We're really, as a database, trying to help developers move faster, innovate faster, deliver features faster, and all in all, deliver more value to your customers, to your internal teams, to the external teams. So that way, that's what MongoDB is here to solve. And with that, we actually have the document model underpinning what we are trying to do. And the document model is what you think of the traditional, or maybe not traditional, but of the document database. So it very often looks like your traditional JSON. We generally actually started as BSON. And because it is so flexible, it can model wide variety of data. We are looking at different key value pairs, graphs, relationships, geospatial data, and all of that data can live in the same database. So if you think back to the architecture that we just saw, where our IoT data traveled from the very bottom of the graph to the top, going through multiple ETL processes, with Mongo, you don't have to do that. You can actually have a lot of different types of data in the same database. And once you can do that, it's much easier to build on top of it and to create a unified interface, where with this unified interface, we can support transactions. We have features like search and mobile, real-time analytics, data lake, and so on. And underpinning all of it is security, distributed architecture, and our multi-cloud. So with this as an answer to the question that we just posed at the beginning, we really need to look at the result. And the result is that Mongo has been consistently voted the most wanted database in Stack Overflow developer surveys. And this is because, or at least to some extent, this shows that the problem that we are trying to solve, we are solving somewhat successfully. Of course, there is always room for improvement in everything anyone does. But what we are trying to address is the ease of use with the intuitive and flexible document data model. We're also allowing your data to be really easy to use with an idiomatic API so that you can easily query your data, even join it or change it so that when it comes back to you, it's the fields that you want may be unbound or aggregated in ways that are expected by your application. And lastly, MongoDB is reliable. So our distributed systems architecture really allows high availability and horizontal scaling, both which are the features that allow MongoDB to take on the amounts of data that we see with IoT. So just to do a little history check, because MongoDB has been around for a while, I wanted to take a look at the evolution of MongoDB. Because, like I said before, MongoDB has been changing. It's not your grandmother's database anymore, though probably never was, since it's only been around for about 14 years. So the big changes that I wanted to highlight is that MongoDB has been changing quite a lot. So, for example, in 2016, we've released MongoDB, or sorry, 2017, we've released MongoDB Atlas. And Atlas is our cloud solution where you can manage your data through MongoDB Atlas, and it can be hosted on any cloud. And it also supports a variety of additional features that can help you transform your data in real time. And with that, we also got change streams and retriable write and ACID transactions, which have been around for quite a while. So MongoDB is ACID compliant. We've also added things like client field level encryption and materialized views, and we moved to defining your own shard keys and adding unions and at the same time we have been adding a lot of cloud functionalities. So once we released Atlas, we also started looking at how we can really leverage cloud in this space, and we are on all the three main clouds. We also support things like AWS IAM authentication. We've also added KMS support for client-side encryption. And in our most recent release in 2021, we actually added specific functionalities for IoT as well, with the time series collections, clustered indexes, and window functions. We're not losing the sight of our focus, which is still on making Mongo as easy to use for developers so that you can develop features quickly and easily. But we are also making sure that we are staying true to being scalable and highly available. And we do that with things like live resharding, which was just released in 5.0, which is really exciting because if you have ever tried sharding a database, it's not always as easy as it sounds. And with live resharding, you can make those changes very quickly and easily on the fly. So if you need to rebalance your shards, you can do that with Mongo.
Hey, Susanna, this is really cool. I mean, I feel like, especially as developers, a lot of us have used Mongo, definitely at least the community version of it. And it's great to kind of see the evolution. Can you talk a little bit about like community versus like cloud version a little bit as well? And for those of you who are just joining us right now, we're here with Zuzana Matavasian, and we're talking about MongoDB. And, she's going to give us a little bit of a deeper insight on working with some real-time data as well.
Okay. Yeah, absolutely. So MongoDB can come in 3 different flavors. We have the community version, which anybody can download, run on your laptop, run whatever you want. It's open source. We also have the enterprise edition, and it comes with a set of more features that are more geared towards the enterprise. So, for example, Kerberos authentication is a part of the EA version of MongoDB. And then there is the MongoDB Atlas product, which can be hosted on AWS, Azure, or Google Cloud, or any combination of those for your multi-cloud or just purely cloud SaaS databases. So those are the different flavors of Mongo, if you will. Okay. So if we don't have any more questions, let's keep going. So Let's talk a little bit in more detail about some of these features that I've mentioned that make Mongo unique and so well suited to really developers. Again, that's why it was voted the most wanted database consistently for the past, I think, 5 years. So one of these is the contrasting data model. So with MongoDB, as I mentioned before, we come with the document data model. And the document data model is flexible by nature. Of course, we have things like schema validation that can help you ensure that the data flowing into your production databases conforms to some level of schema. But changing that schema is a lot less complex than what we see in a traditional RDBMS, where you would need to go and maybe even incur some downtime when you're adding additional fields, or you might need to go through an ORM layer. So with Mongo, adding data in is a lot simpler. It also means that when you're modeling something like what we see on the screen, a customer, for example, who might have sets of data that are not really changing, such as an address. If you live somewhere and you paid that mortgage for 30 years, you're probably not moving that often. That said, that address is probably not going to change. So we can actually embed it in the customer so that when we are actually requesting our customer object from the database, we are not doing 6 touches to the database to find the location, then the geo coordinates, then join it with the customer's information like we would do in a more traditional system. But we do a single touch to the disk to grab all of this data that we need. And I think this is one of the things that is really interesting and very handy about Mongo is how you model your data. Because the world is your oyster with Mongo when it comes to data modeling, it's important to be thoughtful about how you're modeling your data and what really meets your application access patterns. Like if you are never requesting the address for this customer, it probably doesn't make sense to keep it together. But if that's something you're always requesting and you're always going to multiple places to get that information, probably makes sense to store it together. And that's why Mongo is really enabling you to create data models that fit your applications best, rather than constraining you to something that may be unnatural to the data flow that you see within your application. Conversely, it is also very important to be able to access your data. And this is where I wanted to mention the MongoDB Query API, which you can access through drivers, which are written in most programmatic languages. So, we have a driver for Java, for C#, for Python, Node.js. Most of the popular common programming languages are supported. And so you can actually access MongoDB using those native methods within the languages that you are coding in. So once you are doing that, you can create complex queries pretty easily. So for example, you can ask for geospatial data. You can do text search within Mongo. You can do aggregations. You can even do joins when you need to bring in data from different collections, and do things like graph queries with graph lookup. And I mentioned this because very often things like graph or geospatial are not in the first version of your application that you release, but maybe they are in, the 1.5 or a 2.0 version of your app, where you start having those more complex data needs. And at those points, people often reach for various different databases. And we see the same graph that I showed at the beginning, where we have data living in many different silos across your organization, and supporting those products. This way, when you have fairly simple queries such as graph queries that can be supported in Mongo, you might as well add that in without adding the overhead of an additional database. So for some of those kind of edge cases, when you have those features bubble up, Mongo can also support those through our rich and expressive query API. So while all of this all of these different ways of accessing the data is really interesting and can make your application development faster. We also want to make sure that your data is consistent, that it's staying in the database in the way that you expect. And that's where I wanted to touch on our transactional data guarantees. MongoDB is out of the box ACID compliant. So whenever you go and you write to a single document or you create a transaction on multiple documents, they are ACID compliant. So to take a step back from some of these very application-specific things that we are talking about, I wanted to take a look at our architecture. So with MongoDB, we actually are looking at a set of different replicas. So for Mongo, we really recommend having at least 3 replicas, 3 nodes within your replica set, which are copying your data. And that's how we are maintaining high availability, because whenever something happens to your primary node, there is an election and the secondary node takes over seamlessly. Similarly, we also have the horizontal scalability through sharding, which I've mentioned before. So we have things like live resharding that we just released, and it really can help you scale out horizontally fairly quickly and easily. So that's the kind of a high-level overview of what we do in terms of architecture and how Mongo can ensure that your applications stay available, but also can scale out. Sharding can also help with compliance issues such as GDPR, when you need to have your data in a specific geo for compliance reasons or for availability reasons. In fact, there is a big game maker that is using Mongo this way, where the players' data is more closely co-located where they are, and so the application performs faster when the players log in to play the games. So sharding really enables a lot of those use cases. So once we think about the architecture of Mongo, I think it also makes sense to talk a little bit about how you can deploy Mongo. And specifically with IoT, we very often care about deploying your data on the edge, close to the devices or in the devices that are creating that data. So this is where Realm Mobile and Realm Sync come in, which are also supported as a part of MongoDB. We also, like we've mentioned, we have multiple flavors of MongoDB, and those can be deployed in server or in a hybrid cloud or self-hosted. And if you're looking to go with MongoDB Atlas, which is a fully managed solution, that's where the MongoDB Atlas comes in, so that you don't need to worry about your backups, your replica sets, all of that kind of stuff is in the background. You worry about your application, modeling your data, and accessing it.
Yeah, I see that you have, definitely some Openshift is there to, help with deployment of MongoDB. So we'll definitely touch a little bit upon that as well. But I just wanted to pause you here really quick, Zuzana, just because we have a couple of questions from the chat. We have a question from Noah, who is asking about where you can get the full tutorial. Is there a place where you can learn about like all of this? And I know we have some resources as well. So just anything that you can kind of shout out as we go.
Absolutely. So if you're trying to learn about Mongo, and there's a lot of free resources out there to learn about Mongo, I would actually start though with MongoDB University. So you can go online. I think it's university.mongo.com, and we will share the links afterwards, and start taking classes that are specifically about Mongo. We have a developer track and a DBA track. On the developer track, you end up learning about access patterns, different types of data modeling, index building, which we did not touch on at all during this presentation, or well, we might touch on it a little bit later, optimizing your queries, building aggregations. So there is really a wealth of data within Mongo University. And then we also have the DBA track. So if you are, trying to self-host, maybe use OpenShift, you can learn how to be a DBA for MongoDB. And we have certifications to actually go with both of those tracks. So if you are interested, if this sounds like something that is a fit for what you're trying to build, I would encourage you to take at least a few of those classes. And if you're really passionate about it, go get those certifications. Additionally, we have repos on GitHub. We have a YouTube channel that's very active. And we will be posting, like Pusha said, all of these links after this talk.
Awesome. Yeah. And I know we have a lot more going as we go forward, but we actually have another question from Julian, who's asking about time series. So you're definitely going to be touching a little bit on that as well. So as we go forward. So I know that's coming up as well.
Yes.
Yeah.
Yes, we will be definitely talking a lot about that. So we will, that is a part of the presentation a little bit later on. So just to hint on it, we have in 5.0, we have released time series collections with a set of functionalities dedicated specifically to time series, such as window functions and clustered indexes. So we will talk about that.
Awesome. All right, cool. Let's keep going.
Do we have any other questions right now?
We did have one question about customer IDs, but I think that is something that you might have shown a little bit previous. But
oh yeah, I see it.
Yeah.
So to answer that, we can enforce uniqueness, absolutely. The way that your documents are usually created is that MongoDB out of the box creates an underscore ID for any document that doesn't come with a specific ID. However, you can create your own fields to function as an ID. And so if you decide that, hey, I want to use my customer ID as my unique ID, you can do that. And we out of the box index on your unique IDs so that you can find those documents quickly. So hopefully that answers that question. And we can add some, I think, content specifically to answer questions around what kind of constraints you can place on your data afterwards.
Awesome. Cool.
Great.
Yeah, let's keep going.
Excellent. So the last piece that I wanted to mention around how we are deploying MongoDB is by talking a little bit about Atlas. So when we're at a time when a lot of people are moving to the cloud in some shape or form, I think it would be very hard to find a company these days that does not have a cloud strategy. So with that, MongoDB also brings Atlas, which I've mentioned before. And Atlas, as I said, can be deployed on AWS, Google Cloud, and Azure. We have a free tier that you can go and use today. And you can also choose multi-cloud deployments. So if for whatever reason you feel that you need to have your data in multiple places, maybe you're using some Google Cloud functionalities and some AWS functionalities, we can be multi-cloud like that with you. So what comes with Atlas is that we do all of the performance optimization for you. We do auto scaling, and also we help you to scale down when the load on your database goes down. It really simplifies your data architecture. We've heard so many DBAs to just be very happy they don't have to do the administration themselves, and they can really focus on developing features and working with developers to add more value in a way that is very visible. And then we also ensure security. So all of this kind of comes with MongoDB Atlas. So I just wanted to highlight that it's a very easy way to start playing with the database today. So moving on, let's now really jump into IoT. And as you know, Internet of Things is a very exciting space right now.
Mm-hmm.
There is just so much that having sensors and sensor data accessible can deliver. We can see huge improvements in sales and service efficiency, where you can monitor certain devices and take action based on the information. You can get data from even your smartwatches. Mine is not lighting up. But you can also really use these products to deliver on new products, new services. You can optimize your business operations with IoT data. You can also use artificial intelligence and machine learning to derive insights to, again, fuel that optimization of business operation. And you can also use cloud and edge computing to really scale that up. So it's very exciting when we think about all the potential that IoT brings. But what happens here is that let's actually look at some common IoT data architecture just so that we are all on the same page. So when we look at IoT, we have our Internet of Things devices right here. It can be your watches, like we've said. It can be manufacturing. It can be your own house. My house locked me out the other day, which was not a great IoT use case, but all of that data is out there in all of these sensors, and it's coming through, right? And when that data is coming into your traditional or typical IoT architectures, it goes through edge and gateway, and device and mobile. So all of the data is in some way at the kind of the edge right there. And then this data can either go directly into the cloud, or it's going through some kind of an on-prem or a hybrid environment, where either you're directly synchronizing, or maybe there is some pre-processing like we saw with the graph at the beginning, or maybe you're just doing centralized storage because the volume of the data as it's coming in prevents you from taking action on it immediately. And then very often we see some kind of a public cloud come in and help with either the storage or tiering or processing of that data. And then we also see on top of maybe a part of a cloud solution, we see visualizations of this data. We see perhaps some machine learning happening. We see maybe a synchronizations with mobile devices, or even serverless. So all of this is not unusual to see when we look at IoT architectures. And it's really interesting, right? Because you have this very actionable data at a huge volume coming through, and you can do so much with it, just like we talked about. But, and I hate to start sentences with buts, but only 30% of relevant IoT solutions are in company-wide rollouts. We see people who are trying to deliver IoT at scale not exactly deliver it. And it's very often because delivering IoT at scale is difficult. It requires extraction, interpretation, and harmonization of data from disparate systems, like McKinsey noted in this quote that we have. And so we see that there is a kind of a set of challenges that come with IoT, such as the variety of environments where all of this data lives, and also the variety of different types of data. So, your watch data might look, or definitely does look, very different than your weather data, and that looks very different than your smart log data, and that looks very, very different than your turbine data. So this data just looks very different depending on where it's coming from and where it lives. And we also expect very much a constant performance, just because you go to sleep, your Apple Watch doesn't, right? So there is a constant stream of data, and that means that there is essentially almost never any downtime. And we don't want there to be downtime, right? Like, I don't want my smart door to go to sleep when I go to sleep. That would be really, really scary. So this constant performance is really important, but it's also a little bit of a challenge, right? And then the last three I think are also worth mentioning with scalability. So of course, sensor data and IoT data is big data because we're scaling to thousands and millions of devices that thousands and millions of people own. And we're also really still need to integrate that data back with enterprise systems. And very often we need it to be agnostic from edge to cloud. So how do we do all of these different challenges, or even like a portion of these challenges, because these are all fairly complex. And, this is probably not going to be a surprise, but at Mongo, we think that we can address at least some of them, or probably all of them to some extent, fairly well. And that's why our customers choose us for IoT use cases. So let's take a look at what the MongoDB IoT platform looks like. So with this, we see a visualization of where MongoDB fits and where different kind of features of MongoDB fit within IoT. So the first one I want to talk about is the Realm product, the Realm database and Realm Sync, which can be actually embedded and they can be at edge. So Realm databases can be deployed on mobile, on devices, and they can then sync into your larger database. So as far as that part of the traditional architecture, you can use MongoDB there. As we are talking about maybe connecting that data or storing it with MongoDB horizontal scaling, like we just talked about with sharding, really the sky's your limit. You can shard out your clusters pretty far out so that you can take in these high volumes of data. We also support time series, which is something we will talk about a little bit later, natively, so that you can store time series data as time series data. And then we've optimized your ability to query on them so that you can get those data back in real time. So that's just on this level. But once we start talking about the cloud, we see that MongoDB can manage high volumes of hot data. In fact, we have a customer that works with turbines. I think we will be posting the demo or their talk that they did at Mongo Live in our resources. But this customer uses MongoDB to store a lot of their turbine data. In fact, data produced by 6,000 turbines. And they're talking about 25 terabytes of hot data. So all of that data needs to be very highly accessible from the database. And they are able to do 25 terabytes with MongoDB fairly easily. So with that, maintaining hot data that is also highly available is something that we do every day and that we do for these customers that enables them to be successful. Similarly,
Yeah, speaking of that, we actually have a really good question on that. I think we got a question from Fran. Compared to DB2, which one uses much more disk space for the same kind of data, as you're saying?
So actually, that question is trickier than you would think because of what I've said regarding data modeling. So when we talk about comparisons, it ends up being tricky because data that you model in RDBMS like DB2 end up being in different tables, right? With Mongo, you can embed that data into a document. You can bucket it as a part of a document. You can just create time series documents. So it's not really a one-to-one comparison because the data that you have once you migrate to Mongo adheres to your application access patterns rather than your application adhering to your database access patterns, which is more what we see with traditional databases. So, I wouldn't have a good comparison off the top of my head because a lot of it depends on your data modeling.
Awesome. Yeah.
Hope that helps.
Cool.
Okay. So the next thing I was going to mention within the cloud platform, in addition to the volume of hot data that is accessible to your customers, we see we see Mongo's ability to dedicate specific nodes to maybe your real-time and isolated workloads. In fact, with Atlas, you can, or with actually any version of Mongo, you can create nodes that are specifically dedicated to your reads or to your analytical workloads, which means that those nodes essentially host your data, and if you are just reading from them, that's all that they are doing. That's their job. So it's almost like having a separate database just for reads, except it's much more current. So we have functionalities like that. As I said, time series, which we will go into much more detail. We also have, as a part of the platform, that helps you with blended workloads, data locality, which we talked a little bit about before. And the last two features, which I think are actually really interesting, is the data lake storage that you have with Atlas. So you can actually take your data and store it into S3 automatically from Mongo, so that you can have cold data storage as well. And the full text search, which we've released on top of Lucene, where you can actually use Lucene text search to interact with your data. So, that can come in handy for searches on specific cities where people maybe misspell something, or they start typing in and you can autocomplete for the location that they are going for. So full text search can actually be very complementary to IoT use cases, which is a little bit counterintuitive when you think about it, because IoT should be all numbers, but there is enough text for the text search to make a big difference. And then the last few things I wanted to mention here is that with visualizations in real time, we have things like MongoDB charts. We have the BI connector, which is the business intelligence connector, Kafka connector, Spark connector. So if you need to stream your data out of Mongo for additional visualizations or processing, it's pretty easy peasy. And then similarly, we also have additional serverless services that can help you with these kinds of integrations. So it's things like change streams, where if there is a change in MongoDB, we can trigger a function, which is a serverless function in Mongo, in Atlas. We have GraphQL. We have a REST data API that you can use to access your data. So there is a lot of flexibility in building on top of Mongo, especially with these kinds of services. So this kind of architecture and a much, much deeper discussion of what we recommend as a sample architecture can be found on our GitHub. It will be shared as a part of the links after this talk. And I really encourage you all to check it out. It's very insightful. We also, I think, have a white paper that we are sharing about this. So all in all, this can be, you can dive deeper in on understanding this part of the platform.
Cool.
Okay, great. So just to say that we did not pull out this architecture out of a hat, we do have, as I said before, many customers that use it today. So Bosch is one of the customers that uses Mongo IoT architecture, such as the one that we described, for a set of applications. In fact, their software innovations teams, which is kind of spearheading a lot of the work that's done on IoT, has used Mongo as the backend for some of the really cool applications that they've created. One that comes to mind actually is this application that technicians that work on airplanes use. And what they do is that they go in and they adjust a lot of the nuts and bolts and really build the aircraft. And because they are using specific devices to adjust whatever nut or bolt they are adjusting, that drill or screwdriver or whatever is a smart device, and that data is streaming back into the application. So if the technician happens to hold it at a wrong angle, or maybe they didn't screw it tightly enough, the application will alert them in real time that something is not right, that they need to adjust the tool that they are using slightly, or use a different speed or something along those lines. So that is really exciting because it makes flying safer, but it also shows you how Mongo can help you deliver applications or that helps you use IoT data in real time in a use case that is very applicable. And I think that if we all fly, we all really care about this. So, just to help you have kind of a real world example of how you can use IoT data in a real life setting to see this kind of advantage. Okay, so if I have got you guys all convinced that Mongo is the way to go on IoT, let's talk a little bit about data modeling on IoT, and that will be the last part, data modeling for IoT on Mongo, and that will be the last part of what we are going to talk about within the slideshow. Sorry for the long slides, but we will jump right into the demo after it. Any questions so far, Pooja?
Yeah, actually, we have one question, and it's from Kat. So this question is about how does the cost of Atlas Mongo compare to cloud providers' offerings of document databases such as like DynaDB or Firestore? If you have any insight on that.
I really don't at this point, because it depends on what you're trying to do. It depends very much on how you're modeling your data, what your cluster size looks like, what your access patterns look like, and you would have to play with that a little bit. So if anyone has questions such as that, I would encourage you to talk to Mongo directly. And what we usually do as a part of conversations with our customers is that we help to size you for Mongo. We help you figure out what that cost might be, so that it's not a surprise. And that's how we usually handle it. So if you're interested, reach out to Mongo directly. You will work with like a sales executive who can help you figure that out.
Awesome. Yeah, we have this one other question from Bill, and I feel like maybe this is something that I can answer even about MongoDB within the IBM Linux One and the z/OS world. So, yeah, I mean, we can definitely run Mongo through OpenShift operators. We'll be showing a little bit of what that looks like as I kind of walk you guys through the Red Hat Marketplace, how to kind of get a MongoDB operator. And there's with OpenShift being this tool to allow for hybrid cloud development and deployment, it's kind of the way that you can kind of go about running. So we'll dive a little bit deeper towards the end on that, but overall this has been really insightful. So yeah, cool. Susanna, keep going.
Excellent. Okay. All right, so let's talk about how we model and analyze IoT data. So what we have here is really your typical thing that is producing your data. And in a traditional RDBMS, we would have that thing as well as additional information about it. So, it can be any number of things about the actions it does, relevant properties, the relevant schemas that we have for it. And you can see how easily and quickly this kind of keeps bubbling. So what we see here is the kind of complexity that we started off talking about initially, where you have your data living in different places. And what we see here is that we also run into questions around, how do we translate this? How do we represent this? How do we change this as we go on? How do we do more with it? But this might look a little bit different in Mongo. So, your strict schema that is more traditional for RDBMS we look very different in Mongo just because of the flexible data model. Moreover, this makes Mongo also extensible at runtime. So if you need to add specific data into Mongo and just make it more extensible, you can do that here. So we actually use it for standards like JSON LD, which is a part of the semantic web. So all of this is a part of what we are doing here. So when it comes to actually modeling your data, there are different ways of doing it. One would be bucketing. So bucketing is very interesting because it allows you to embed maybe data such as time series into into a document that has your other device data. So for example, in this case, we see the device ID, we see the number of measurements in this specific bucket, we see the most recent data in the bucket, and we also see the actual individual measurements. So you can do that maybe on a per day basis or per month basis. So it's one way that you can certainly model IoT data within Mongo that very often meets some of the IoT use cases that we see. However, that's not the only way. We actually have a native time series thing. We have a native time series feature that we released in MongoDB 5.0. And the time series collection allows you to store time series data natively and also query it much more natively. And what it really does is that as your data for a specific device is coming in, that data is getting stored in the same chunk on the disk. So let's say that Pooja's IoT data is coming in from her watch, and my IoT data from my watch is coming in. And instead of in a more kind of typical setup, you have her data going, then my data, then her data, then my data, then her data. Yeah, it just keeps going like that. And so when you try to query it, it becomes more problematic because you have to go to many different chunks on the same disk. With the time series collection, we store the data per each device in a separate chunk or a separate set of chunks, so that when you're querying on that data, it's just going through that one chunk or one set of chunks rather than scanning all the different chunks of the database. So that's one of the main differentiators of why using a time series collection is actually really helpful when you're looking at time series data and really querying that data back through your application. We also released a set of features such as the clustered index and the regular index, which is different than the regular indexes that we have in MongoDB. Mongo comes with a wide variety of indexes, ranging from compound indexes through unique indexes, geospatial indexes, text indexes. So there is a lot of indices that you can have in MongoDB, but the clustered index is unique because it is specifically useful to time series data. It's more similar to a dictionary than like a traditional index because data is sorted and stored together. You also can only have one clustered index per collection. And what you have here is that with the clustered index, you can really quickly and easily access a range of pre-sorted data. You can't really do that as well with a regular index because regular indexes are much more suited to random access patterns to the data and less so to this pre-sorted way of accessing your data. So that's something that you can take advantage of now with 5.0. And in terms of querying it, and I know we had a question about this before, is that we actually see the window function that helps you aggregate data so that you can see specifically a window of the data that you want to use for your application. So a window can be something like 1 year or 1 minute or 30 minutes. So whatever time window you specified for your application, you can chunk your data in that way and access it and view it that way with this specific aggregation. And I know we haven't talked about aggregation in too much detail, but this is what an aggregation look like. Aggregation, you can think about it as almost a pipeline, like when you are piping something in Unix, where the output of one stage is the input for another. So in this case, we only have one stage, but the data is going through this one stage of window fields. But maybe if we wanted to do some kind of numeric operations on it, like add it all up or something along those lines, we could do that. So we could get total of, different, in this case, cakes sold per year per type or something along those lines. So that's what you can do with aggregations. And with the window function, you can do it for a specific time period of your data much more easily than before. And lastly, we also have the MongoDB chart support for time series data. And what this allows you to do is that you get to visualize your data within MongoDB in real time. And it's pretty interesting because this way you can see your visualizations very quickly, and you can just do it from a browser. You can also embed them into your applications using the chart SDK that is also supported by MongoDB. So this is how we have really moved towards addressing some of the needs that we see in the IoT market. And to wrap up, what we really help you do is that Mongo is there for the entire full data lifecycle management of IoT data, from ingestion through storage, through accessing it, analyzing and visualizations, all the way to tiering it so that you can, separate your hot data and cold data storage, for example. And just to wrap up, we went through the IoT data example in this talk today, but we have many similar examples across different industries where Mongo, because of the extensibility of the document model, can really support a wide variety of use cases, whether it's financial data, whether it's IoT data, whether it's gaming data, like I've mentioned before. So there is a lot of use cases that are supported by Mongo, because MongoDB is a general purpose database that allows you to model your data in so many different ways. And so I would really encourage everybody to take a look at some of the resources we are sharing, as well as our website, to kind of see how this kind of data platform can really move the needle in a variety of different industries.
Awesome, Susanna. So, before you kind of go into the, real world demo, I just wanted to just level set with everyone. If you're on Crowdcast, you should be able to see this link at the bottom that says resources. So if you click on that, it should be a public gist, and just ping in the chat if it is. I believe it should be a public gist, but feel free to check that out. That has all of the resources, some of the stuff that Susanna talked about MongoDB University, as well as some getting started with MongoDB guides, 101 basics with MongoDB, data modeling with MongoDB. So, she definitely went through so much content today, and kind of talked about the entire gamut of this of all the use cases there as well. So, but before we do that, I just want to kind of talk about one other use case. One other question that we have here, Susanna, from Nick. So Nick's question is, if you store JSON LD, does this allow you to query using SparQL? If you have any thoughts on that?
I'm not sure off the top of my head, but we can try to get back to you.
Okay, awesome. And ideally, I feel like, just a little bit of Q&A with you, Susanna, since, you have so much insight in this space. You've kind of talked a lot about, the market, as well as, different strengths of the MongoDB platform. But the one question I have for you is what's some of the major things that you think that developers and architects consider when they go about choosing their database platform?
So, I think there are sets of considerations that are universal, but then obviously you also want to make sure that whatever tool you're choosing is the best for the application that you're creating. So in terms of universal criteria that people look at, obviously you want to make sure that your data is safe, that it's secure, that it's consistent, ACID compliant, of course. Scalability is something that continues to be a differentiator for MongoDB, just because we do scale very well with the volume of data. So especially as your data grows and continues to grow, that's something that we see a lot. High availability is also very, very important. Nobody really wants to have application downtime, whether planned or unplanned. It can be a major pain point for a lot of organization, and one that has can have a lot of repercussions in terms of brand revenue and so on. So I would say that being able to have a database that is always up and that is not causing your application to go down is one of the universal criteria that we see. So I hope that answers some of your questions around what people are looking for.
Awesome. All right. So let's dive right in. I know that you have some cool hands-on sort of demos, at least with the platform. So I'm excited to see that as we go forward. So yeah, let's dive in.
Okay. Let me just switch screens here for a second. All right. So great. So right now, what you see in front of you is the Atlas UI that comes with MongoDB. So like we've mentioned before, this is how you can administer your database directly from your browser. And what we have here is a specific cluster. So this is a 3-node cluster like we've talked about that is deployed in US East. So this is what we have right here, along with a set of database metrics to tell you how your database is doing right now. Now let's actually look into specific collections. Well, I think I zoomed in too much. My apologies, guys.
No worries.
Okay. So let me just show you exactly what the DB looks like here through one of our tools called Compass. So if you're actually interacting with MongoDB, there are many different ways you can interact with it. So for example, you can use command line, you can use the drivers within the application that we looked at, or you can also use our tool called Compass, which is
just 1 second. I think we need to just share your screen again.
Oh, I'm so sorry.
Yeah, no worries. Yep. And for those of you who just kind of joined and are just joining us as we go, we're going through some live demos of MongoDB platform. So thanks for joining us all at this point.
Okay, so let's see if I can share this correctly now. Apologies, guys. Okay. So right here, we have our MongoDB Compass UI. Let me zoom in so that
Perfect.
Hopefully it did not crash my browser this time around, or rather this application.
Okay, great.
So what we have here is that this is essentially a UI tool that you can actually use to interact with your database. And it essentially works as just a GUI on top of your DB so that you can connect to it. You can see the different collections in your database. And in this case, I put together a heart rate and sensor data database to answer Pooja's questions that she had when she initially called me about how she can use some interesting IoT data from her watch. So what we have here is the heart rate sensor data. And generally, this is the way we model the data, where we have the timestamp. We have, in this case, object ID, which, like I said before, you can actually specify yourself. You have the actual heart rate that she's recording, and then the watch ID. In this case, this is my watch, but I'm sure we have some that are, from different watches, and also from Pooja's watch. So this is how your data is going to look like in a time series database. We're also, telling you that this database is specifically time series, as you can see right here in this little visual. So that makes it a little bit different than our traditional database right here. When you are creating your database, if you do it through Mongo SH, you can do it programmatically, but you can also do it through a UI like this, where you can say, hey, I want a time series collection. You can type in your collection name, and you specify your time field. So this is the field where the time data is going to be recorded. In this case, our time data is timestamp. Our time field is timestamp. The time field can be anything else. You can call it, time data field, or whatever you want to call it. And then the metadata field is actually really interesting, because if you think back to what I was saying with time series and chunking the data on disk, this is how we do it. So for us, in this example, our meta field is actually the watch ID, and we are essentially splitting the data so that all of Pooja's data lives together in its own set of chunks, while my watch data is going to live in a separate set of chunks, so that when you query it looking for my data only, it's only going to look at the chunks related to my data. Similarly, if you are going to just look at Pooja's data, it's going to look just specifically on the chunks for Pooja's data. So that's the optimization in terms of querying it. For granularity, we can actually choose whether we are looking at seconds, minutes, or hours. And that way you can decide how granular you want this time data to be. And you can also expire it. So you can maybe say, hey, this data is not relevant after a day. We only need it for a day. Afterwards, we can, before that, we can offload it. We can maybe just delete it or whatever it may be. So this way, you can actually expire it pretty quickly and easily. So this is essentially what the time document looks like, and that's how you would go about creating a time series. Like I mentioned before, you can also model your IoT data differently with bucketing if you want to have additional information in relation to the time series data that we see here, or if you have different access patterns or different data modeling that you need to satisfy. So that's how we would handle this. So now let's talk a little bit about visualization. This is where I'm going to switch into our Atlas UI, and specifically to charts. So with MongoDB charts, we can actually create visualizations on the fly of the data that we see coming into our cluster. So let's open just a new dashboard here. In this case, this is just an IoT data dashboard that I have created as a placeholder, but we haven't created any charts. However, we can easily add charts right here. And we can do that by choosing a data source, such as the heart rate sensor data right here. And we can choose also the kind of visualization we want. So we can have bar data, column, combo, line, area, grid, circular, even like tables and geospatial data, where we can actually generate a map of specific location, and we can show a distribution of data points along that location. So just for simplicity here, though, let's go with a line graph. And let's map a timestamp on the minute data, because that's what we have for our heart rate data. And let's map our heart rate data using distinct values on our timestamps. Lastly, let's also add our watch ID as the series, so that the different watch IDs will be separate here, so that everybody's data is just going to look a little bit different. So this is how you would go about creating MongoDB chart with just a few clicks. What is interesting here, though, is that we also allow you to query your data or create aggregations as your data is flowing in. So, oh yeah, it took a little bit of time just because your data, the data we have here is IoT data, and it's quite large. So we just ended up waiting for a second, but once we have the data, once we have the chart generated, it can update automatically. So as I was saying, right here, because we're able to add in specific aggregations, such as the one that we saw with a window function or specific queries, we can also change our data the way that we are displaying it. So for example, if we just make this so that we're looking for metadata watch ID that's Pooja's, and this is how our query looks like. It has to be a valid JSON object, just because that's the syntax that MongoDB query language uses. We can apply it, and now our data is just going to be Pooja's data by herself, rather than all of this other data that we saw before.
Yeah, wow. Okay, this is pretty cool, Zuzana. I think this is a really interesting way to definitely visualize a lot of stuff. I like that you can definitely filter some interesting data and do some really cool modeling. We have one question, and it's from Andy. So the one question we have is, does it integrate with DB2 as well? Can you integrate DB2 into this as well, or do you have any thoughts on that, or in general?
So what we see people doing with between DB2 and MongoDB is that sometimes they use Mongo as an operational data store on top of DB2. So for example, let's say you have a lot of legacy data in DB2, but you need to access it more quickly and easily and interact with it more quickly and easily as you're building new applications. You might have a MongoDB operational data layer sitting in between. So we've seen architectures like that. It really depends on the use case, though. I would probably want to ask Andy a little bit more to understand what he means by an integration, what kind of a use case is that, and that way we can talk specifically about what that would look like.
Yeah, definitely. Awesome.
Great. Okay, so the last piece that I wanted to show you here is that as you create these dashboards with data that perhaps is not as colorful as this one, you can also share it pretty easily. So you can share it either within people in your organization with specific users. You can also embed this kind of a chart into your web pages, either through sorry, I haven't configured authentication here, but you can embed it specifically into your application just as an iframe. You can also use the MongoDB SDK to embed this into your applications directly. So there is a lot of flexibility in how you use charts to go beyond just like the MongoDB UI. This is kind of like a functional way of saying, hey, I can see my data in real time, and it's really interesting and it's exciting. But if you want to really productize it, we have multiple different ways that you can take this kind of visuals and make sure that it works within the applications that you are creating. So cool. I hope this was helpful in terms of a demo.
Yeah, no, this was really cool. I remember you and I were talking earlier, and you had shared with me this GitHub link as well. I don't know if you have it on you, but you were talking. It kind of showed like geospatial data. I thought that was really interesting. Like that it can also map different, like location geospatial type of stuff. So Yeah, I think that's a cool example if you have it on to pull it up. But otherwise, I think this is really interesting. It seems like you can get some really deep insight from it. How would you describe like the ease of use? Like, is it a pretty intuitive tool to learn overall?
I mean, I've been talking a lot about how we try to be the tool for developers because we are simple to use. So I think as far as ease of use goes, it is very intuitive, very easy to learn,
Hmm.
just because a lot of the queries are written, like I said, in JSON like
Hmm.
structures where you can kind of see where there are mistakes really quickly and easily. You know, if you have ever
Hmm.
tried troubleshooting like um, connection string for a traditional database, it's a string. There is nothing telling you, you know, like, oh, you're missing like a parentheses right here, or, you know, you're doing something wrong here. So it's not, at least to me, as readable. But with Mongo, the MQL language allows you to see your mistakes really quickly and really easily, so that you can kind of quickly make those changes. And because we have the native drivers to whatever language you're working with,
Hmm.
it's kind of a no-brainer, you know, because if
Hmm.
I am, you know, like a Python developer, I'm just doing everything in Python. If I
Yeah.
am, you know, a Java developer, I'm doing it in Java. So the ease of use is kind of really the front and center of what we are doing here.
Yeah, no, this is awesome. Actually, we have a great comment from someone that's watching, Jay. He said that's a great presentation with different chunks of great examples mixed in with technology that's definitely remembered by someone who's even new to this. So thanks so much, Jay, for watching and following along. So we have about 15 minutes left, a little bit less than that. And so I kind of wanted to wrap it up with a couple of insights just to talk about where MongoDB kind of fits into the whole world of IBM and as well. So I wanted to go forward and talk a little bit about, let me just kind of go back a little bit. Sorry. Oops. Can I get my slides back up? Sorry. Yeah, great. So I wanted to talk a little bit about the Red Hat Marketplace. And so the Red Hat Marketplace is, it's a open cloud platform that allows developers to kind of get technology from different uh, uh, areas. And the idea is you get these pieces of technology and they're container based. So you can kind of basically uh, connect them relatively succinctly through a Red Hat Openshift cluster. And I'm going to show you what that looks like as we go forward. But essentially, you're able to kind of, deploy things from public cloud, on-prem, different developer stations as well. So just kind of breezing through the Red Hat Marketplace a little bit. It's a great software tool, and it's an all-in-one platform that's managed by OpenShift, and you can kind of deploy it across different cloud platforms, and you can use operators to kind of connect to different technologies, and we'll show you what that looks like when it comes to MongoDB. So essentially, what exactly is an operator? So an operator is a piece of software that basically makes it a lot more easy to run without dealing with all the complexity of installation and packaging and deploying. And you can kind of install these operators on top of an OpenShift cluster. And I'll show you what that kind of looks like as we kind of go forward. But there is a IBM MongoDB Enterprise operator, and this one is actually provided by IBM. And it includes things like things that Susanna has talked about. Some of the databases, query languages, in-memory speed, and in intuitive GUI as well. So with the MongoDB operator, you can actually install that using Red Hat Red Hat Openshift. So I just wanted to give you a little bit of insight, if we kind of pull up my screen, a little bit on what the Red Hat Marketplace looks like. So this is what the Red Hat Marketplace looks like. There's tons of different products here, and these are all different products that you can kind of go about installing through an operator. So this is the MongoDB operator that's available through the Red Hat Marketplace. And essentially, we have some code patterns on how to get started with this operator, but it allows you to kind of install this in a really seamless way, as well as like upgrade it as well. And you can kind of get some more deeper insight on how to do that here. So we actually have a code pattern. So at IBM Developer, we'd like to create these things called code patterns. So this is a code pattern about securing a MongoDB operator with OpenShift. So this is something, if you're interested, if you get your hands on a cluster as well, you can kind of go through this and kind of get started with a MongoDB operator. And we have some colleagues at IBM that have done an amazing hands-on workshop talk to this. So this is the session they did it actually earlier last March. So you'll kind of get a deeper understanding on how to use the operator there. So yeah, overall, I just wanted to share, a couple of those things as well, and share some of those insights. This session was really useful, and I believe that I've shared the gist with you all. So Zuzana has been a wonderful, wonderful host today. And, if you are interested in learning more, I've actually added a couple of our profile pages there, but tons of resources here. The MongoDB manual, as well as the MongoDB University. I wanted to share Zuzana's that geospatial GitHub link, which I thought was really cool. So this was another really interesting thing that you could do with some geospatial data that Zuzana had shared with me, which I found this one of the most interesting features of MongoDB as well. So being able to kind of build out heat maps and work with location data as well. So really cool visual stuff. Yeah, so this is pretty much what I wanted to share with you all. And, it's been an amazing session with you, Zuzana. So I really appreciate you kind of coming on board and giving us all some really great insight into MongoDB, a lot of what we can do with some IoT data. Yeah, and it's just been really wonderful. So thank you so much. Do you have any last things you want to say?
Thank you so much for having me. This has been a really fun session. Thank you everybody for watching and for all your questions. If you want to talk more about Mongo, I would absolutely love that. So feel free to reach out on LinkedIn with any questions or whatever else. So looking forward to hearing from you all.
Yeah, awesome. Thank you so much for joining us today. This has been a really deeply insightful session. And yeah, I appreciate you all kind of taking the time to hang out with us. So, yep. Have a good one, everyone. We'll see you later.